Hello, Bronx Middle School Math. We are going over some lesson 5 practice problems. And some of them might take some time, so if you're good on this problem and you want to get some variety, feel free skip ahead, but always take notes when you're watching these videos. That's the purpose of these videos is to learn how I got the answer. Don't just search for the answer, search for the method. I'm sure y'all have heard the saying, but my parents used to tell me this all the time. They would say, give a man a fish, you feed him for a day. Teach a man how to fish, you feed him for a lifetime. So that's what these videos are. They're to teach you how to fish, feed you for a lifetime. All right, so let's get started. Lars has written a song for the upcoming talent show at school. The song is 24 measures long. Lars sings for 1/6 of the song, raps for 3/4 of the song, and the rest is instrumental. Answer the questions below. So before I even go to the questions below, I knew that I was going to need a number line. And I made it 24, as you can see. And I'm sure the reason why you know I made it 24 is because the song is 24 measures long. And I'm not going to lie, I do not know anything about music. I don't know what a measure is. But I'm sure I know enough about math to compensate about my ignorance for music. So let's go to the questions. For how many measures of the song is Lars singing or rapping? Singing or rapping? Okay, so let's go to the question. Okay, so Lars sings lyrics for 1/6 and then raps for 3/4. So we're going to do 1/6 plus 3/4. What is our common denominator for 6 and 4? Well, for 6, I know the products are 6 are going to be 12, 18, uh, 24, 30, 36, and 42 for good measure. Now let's go to 4. Okay, 4. The products of 4 are 8, 12, 16, 20, 24, and 28. Okay, so which products do they have in common? The product they have in common will be our common denominator. Again, I repeat, please write this in your notes. The product they have in common can be the common denominator. The product they have in common can be the common denominator. So let's see what numbers they have in common. I see 12. They have 12 in common. I don't see 18. I see 24. Boom. I don't see 30. Okay, so let's stick with 12 and 24. Well, I'm going to make a smart decision. 12 could be the common denominator, but since our number line is 24, let's be smart. The song is in 24 measures, so let's make that our common denominator. Let's work hard and smart. So our common denominator, let me write that. Common denominator equals 24. So let's manipulate these fractions so that we get 24 as the denominator. So I'm going to go up here and do that work. I want to make sure I have enough room. So 1/6. Then we're going to add 3/4 equals 24 plus 24. So I already have our denominators. This is what we're reaching for. So how do I make 6 into 24? What do I need to do? How do I manipulate it? What do I multiply it by? Well, 6 times 4 equals 24. So whatever we do to the denominator, we have to do to the numerator. Now, how do I manipulate 4 to get 24? 4 times 6 equals 24. So 1 times 4 equals 4. 3 times 6 equals 18. So how long does Lars spend singing or rapping? It is going to be 22 over 24. So 22 measures out of the total 24 measures are spent singing or rapping. But since now we have manipulated fractions, we can label it. So it says 1/6. So we manipulated 1/6 into 4 24ths. So actually, I'm going to erase that and do this. Watch this. Okay, so then now we're going to do, so 4 out of 24, that is spent lyrics. Okay, now let's do raps. How long? So another color I can use. I'll do purple. Okay. So raps. Oh, that's a bit off. So 18 out of 24. And that takes us to 22. So see how we use the number line to confirm and check our work? Let's go on to the next question. For what fractional part of the song is Lars singing or rapping? Well, we already found that out because see, look, we found 22 out of 24. So 22 measures were spent, but 22 out of 24. Let's simplify that. Let's divide it by 2. Let's divide the numerator and denominator by 2 and see what we get. That's going to be 11 over 12. So that is going to be the fractional part of the song that is spent rapping or singing. We could say 22 or 24, but if we simplified it, it's going to be 11 over 12. How many measures of the song are instrumental? Let's go back to the question and see what it tells us. It tells us that the rest is instrumental. So the whole song is going to be 24 over 24. That's one whole. But as we can see, 22 out of 24. The remaining part is going to be 2 measures. 22 subtracted from 24 equals 2. Oh, wrong color. What fractional part of the song is instrumental? Well, 2 out of 24 measures are instrumental. If we reduce that, let's divide by 2, the numerator and the denominator by 2. So, oh, forgot the 2. So 2 divided by 2 is 1, and 24 divided by 2 is 12. So 1/12 of the song is instrumental. Okay, here's our next problem. Noah, Isaiah, and Zoe were running a relay race together. Noah ran 5.6 kilometers, Isaiah ran 2/3 kilometers, and Zoe, is it Zoe or Zori? I'm sorry, Zori ran 3/5 kilometers. What was the total distance of the relay race? So one thing you have to know going into this problem is what a relay race is. And that's where someone runs with a baton. You know the baton? So you run with this baton and you hold it while you run. That's my drawing of a grip around a baton. So you run with the baton, and so Noah's going to run, da, 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 and then he's going to hand it off to Isaiah, and Isaiah starts running. And then he's going to hand it off to Zori, and Zori starts running. So it's one person running at a time, but you want your team to win. So we are trying to find the total distance of the relay race. And by doing that, we are going to add up how far each person ran. So we're going to do 5/6 plus 2/3 plus 3/5. And I need to find a common denominator, a product that 6, 3, and 5 all go into. And I'm going to be strategic here. I'm going to list off the products of 5. So 10, 15, 20, 25, 30. Let me move that over. I'm doing 5 first because I feel 5, those are round numbers that are easy to check. So I'm going to be checking 3 and 6. Can 3 go into 10? Nope. Can 3 go into 15? Yes. Okay, so can 6 go into 15? It does not go into 15. Okay, can 3 go into 20? Nope. Can it go into 25? Nope. Can 3 go into 30? Yep. Okay, let's check 6. Can 6 go into 30? It can. The reason why I'm not checking if 6 can go into 10, 20, or 25 is because all 3 need to go into this number, into this product. So if 3 can't go into 10, it doesn't matter if 6 can or not. It already doesn't matter. So we go for ones that all 3 can go into, and that is 30. 30 is going to be our common denominator because it's a product of all of those numbers. 5, 3, and 6 all have a product of 30. So I'm going to do some cleaning. So our common denominator equals 30. So let's manipulate these fractions. I'm going to zoom in here. So how do I get 6 to 30? 6 times 5 equals 30. Okay, how do I get 3 to 30? 3 times 10. How do I get 5 to 30? 5 times 6. Okay, now let's see what the new fractions would be, the new manipulated fractions. So none of the denominators are going to be 30. Let's see what the numerators are going to be. 5 times 5, 25. 2 times 10, 20. 3 times 6, 18. Okay, so now I'm adding all these up. 25, 20, 18. 5 times 8, 13, carry the 1. 2 times 2, 4, plus 1, 5, 6, 63. So I have 63 over 30. As you can tell, improper fraction. I need to turn that into a mixed number. So 63 out of 30 kilometers. Let's turn that into a mixed number. So to make that a mixed number, I'm going to do some division. 63. So 30 63 divided by 30. How many times does 30 go into 63? How many times does 30 go into 63? Well, 1 would be 30, 2 would be 60. Okay, so let's do 2. That'd be 60. 2 times 30 equals 60. I subtract, and the remainder is 3. So I have 2 and 3 over 30. I can simplify that fraction a bit. Let's simplify it again. So I can't divide by 2, but I can divide by 3. That works out. That'll give me a whole number. So our final simplified answer is going to be 2 and 1 over 10. So how many kilometers did they run total? It was 2 and 1/10 of a kilometer, or kilometers. All scholars in grade 5 play one sport: soccer, basketball, or baseball. 7/12 of the grade plays soccer. So 7/12. That's going to be 7 over 12. 7 and 21, 7 out of 21 plays basketball. And the rest play baseball. What fraction of the grade plays baseball? Well, we need to find a common denominator for 21 and 12. So let's look at the products of 21. So I know 21, 42. What else do we have? 63. What could be another product of 21? Let's do one more for good measure. Okay, now we're going to do 12. I hope you know your times tables for 12. So 12 times 2 equals 24. 12 times 3 equals 36. 4 is 48. 5 is 60. 6, what is 6? 72. 8 is 84. Let's do 9 just to be safe. So what product do 21 and 12 have in common? 84. That is going to be our common denominator. Now remember, I want to get to 84. So 12 times what equals 84? Okay, now let's move on to the next fraction. 7 over 21. We are multiplying it, and we want to get 84. So how many times does 21 go into 84? 1, 2, 3, 4. So I need to multiply 21 times 4. 7 times 4. 28. So what fraction of the grade plays baseball? So I know so far I have 49 over 84 plus 28 over 84. Let's figure out how many. Okay, so 49 over 28, 17, 7. 77 out of 84 play soccer or basketball. The remaining are going to play baseball. So the fraction equivalent of those who play baseball. So we know the total pieces are going to be 84. So 84 minus, oh, that's a long minus sign. 77. All right, so 7. The fraction equivalent of those who play baseball are going to be the remainder of 84 minus 77, because 77 is the total number of kids who play soccer or basketball. So this number is going to be number who play baseball. So the fraction of that is going to be 7 over 84. That is the fraction equivalent, because we're going to put the kids who play baseball over the total number. So let's make sure we put our answer nice and clear. 7 over 84.